Now we have an idea of what a binary search tree is. Now let's try and add some nodes to our search tree. Let's talk about adding or inserting a node to a binary search tree. Now in the previous video, introducing us to binary search trees, we discussed what nodes are, how to create them, but now we would like to add them and build a binary search tree, and that's exactly what this video is about. So at the end of this video, not only will you learn how to code the add node function, but you'll understand how it works. Welcome to CentralStack Fundamentals, and if you're new to the channel, welcome and please subscribe. The add node function is simply allows us to add nodes to our binary search tree. But we have to follow a few rules while doing it, which I will show you in just a second. But at the end, we want to be able, for example, to add a node with a value of 15 and have our function place it in the correct position. In this example, 15 is greater than 12 and is added to the right pointer of 12. Same thing if we added a node with the value of 10. Let's quickly go through the process of adding or insertion using the examples of a node with value 15 and another one with the value of 10. Now to insert a node in the correct position, we have to consider its value and compare it to other node values, starting at the root node. While doing this, we have to keep two things in mind. If the node value of the node you are currently adding is less than the node value of the node you are currently comparing with, we add the node to the left pointer of that node. And if it's greater, then you add it to the right pointer of that node. So we have an example of a binary search tree, and we will add the node with the value of 15. I will guide you through on how it is done, starting at the root node. The root node value is 7, and we're adding a node with the value of 15. 15 is greater than 7, so we're going to the right pointer of the root node, but it is already pointing to a node with value 12, and that becomes our current node we compare with. And now we repeat the process again. Our node has a value of 15 and our current node value is 12, and 15 is greater than 12, so we go to the right pointer of the current node, but the right pointer is pointing to null or to nothing, so there is no node to compare with. Therefore, we point the current node's right pointer to the node we are adding. And that's it. We've successfully added a node to a binary search tree. Now let's make sure you really understand. I want you to mentally visualize how we go and add the next node with the value of 10 as I go along with you. Now starting at the root node, we're adding a node with value 10. The root node value is 7 and 10 is greater than 7. So we go to the right pointer of the root node and we get a node with a value of 12. Now 10 is less than 12, so we go to the left pointer of the current node and we get a node with a value of 9. And 10 is greater than 9, so we go to the right pointer of our current node, but it is currently pointing to null, so we'll add our node here. Well done. We've just added two nodes to a binary search tree. We're almost done. I'll show you the code that makes all of this possible, and yes, I'll explain the code, and using some animation I'll show you what it does at the same time, and I'll show you the project files in just a moment. To start, we create an add node function in the PST file, and it will only take in the value we want to add as argument. This function only calls another function, the add node search function, which will be concerned with only finding the correct position to add our node. This function only takes in the value of the node to be added and a pointer. Since we start searching or comparing values at the node, we will pass the root pointer as argument. Now let's talk about what happens when the add node search function is called. First, we check if the root pointer is equal or pointing to null, meaning the tree is empty. If that's true, we set the root pointer to the node we are adding, and it becomes the root node. Okay, the second case is where the root pointer is not null. For this one, let's say we're adding a node with a value of 6. So we call the add node passing 6 as argument, which calls add node search, taking in 6 and the root pointer as arguments. And now starting at the top, starting at the root node, 6 is less than 12 and the left pointer is not null. So we recursively call the add node search function with the same add value, but we call the add node search function with the same add value, but with the left pointer as our second argument as we're moving down the tree. And now we check at that position. 6 is less than 10, so we enter the else if statement, but the left pointer of our current node is null, so we skip the if statement and get to the else, where we point the current node's left pointer to the node we are adding. Okay, so follow along visualizing as we add a node with the value of 17, starting at the root. 17 is greater than 12, so we go to the right pointer of the root node, which is not equals to null, so we recursively call the add node search, but with the right pointer as our second argument, moving a level down to the node with value of 15, and 17 is greater than 15, but the right pointer of our current node is equals to null, so we point the current node's right pointer to the node we are adding. And if you add a node that is already in the tree, that will be captured by the else statement, and it won't add another copy of the same node. Great job, we have successfully added nodes to a binary search tree, and now we understand how it works and we have seen the code that makes it work. As I previously said, I'm working on a document that will be a guide to data structures, going through the types of data structures and explaining them, using illustrations and going through some example codes, applications of data structures. So hopefully by the time you're watching this, it will be linked down in the description. So I suggest you turn on notification, and I'll let you know when the material is ready. Please take 10 seconds to subscribe, because I'm growing this channel and believe in free content. So please like and share this video with at least 5 people who will benefit from this video. Please leave your questions and comments in the comment section below, and I'll respond as soon as possible. This is CentrusLearn Fundamentals, and we're inspired to learn.